In today's Retro Tech Repair, we're going to be trying to fix this Entex Space Invader that has had a really dangerous mod. And we are going to go straight into the eBay listing for this one. Vintage 1980s Entex Space Invader electronic tabletop handheld game, plugged. I paid $5.99 and £3.50 shipping. And we'll take a look at the seller's description. Untested, sold for spares or repairs. That's it, that's all I got. No explanation as to why it was plugged or what the plug meant. So it really is a bit of a mystery for this one. Let's have a look at what actually we have in here. One of the reasons I wanted to buy this, firstly because I like to bring unique things to the channel, but secondly because I don't want this kind of plugging into a main supply if in fact it's not meant to be so. Anyway, it comes in a nice box from the Cocktail Man, London. And there it is. And it's very grubby, and I immediately noticed that yeah, it has on it a 2-pin plug. How fascinating. I notice also the fire button is in the incorrect orientation. That's not a huge surprise, but fire is written in the kind of upwards orientation there. Probably just misassembled when it was presumably reassembled after this modification. A few marks on the back, that might be a berm. Probably it's just from a plasticizer and a cable, something like that. Obviously the instructions are worn off the back. There's a few more marks. And then inside, the battery contacts have all but gone, unfortunately. Perhaps that's why it saw this modification. But yeah, what a crazy mod. Really, that is madness. The connector is marked 250 volts. Let's see if we can connect that into something. Alright, so let's see if we can find some things that we could plug this into. I'm going to start off with a UK shaver adapter. This is a adapter that you'd use in the UK if you had a kind of shaver adapter or shaver plug that you wanted to plug into a UK socket. So first of all, does it fit that? Oh yes. Oh yes, perfect. Absolutely. So this Entex Space Invader could be plugged directly into the mains. Isn't that crazy? Wow. It's really going to be interesting to tear inside of this and see how this is connected, but this direct connection to the mains is really quite something. Alright, so let's bring in my AC transformer here, and I'll plug this into the UK power. I should point out that the transformer isn't plugged into anything, so this is perfectly safe. What I'm trying to do is just illustrate the connectivity options for our handheld game. Yeah, so we have a US 110 volt outlet. Not sure that's normally US because I don't see the round pins in the US, but we'll try it. So yeah, 110 volts straight into our Entex Space Invader. Great. And then if we are in the EU, we can plug straight into our 230 volts EU outlet with it too. How mad is that? And then in the UK, great, with a little bit of adapter straight into a UK shaver socket too. Absolutely crazy. So in every country, or a lot of the countries in the world, I could get this with 230 or 110 volts in my hand. I'm really curious to see what is inside here. I'm deeply suspicious that in fact this might just be connected straight to the battery terminals in here. I suppose there could be a diode or a transformer or something like that, but you know, it looks like it would be just connected directly to the battery contacts. So let's take a look. Oh yeah, it's connected directly to the battery contacts. And in fact, it looks like it's not even soldered in. It's just kind of wrapped around there. How incredible. So yeah, I don't know, that would be a very bad day, I think, when you ended up with 230 volts going directly to this. Now, if you know, by the way, where this is supposed to go, if you have an idea, I mean, it is marked 6 amps, 230 volts. Yeah, if you know where this is supposed to connect, if you have any idea where this could have gone, I actually Googled kind of Scalextric's transformers and common kind of Hornby train set transformers and things like that that might have an output like this, and I couldn't find anything. So if you know where this is supposed to go, please do let me know. But yeah, it is just wrapped around the battery contacts right there. Alright, so let's see if we can get this cleaned up now and do something with it. Maybe we can get it to play again, but certainly not by plugging it into the mains. The way that these work, by the way, is that it's an LED game, a Space Invaders game, and it's a matrix of LED displays with a kind of grid over the top, a little grating. It's stuck in place in this one. I think I've seen them where they are not stuck in place, but beneath that it's just a normal light emitting diode, or actually I think it's mounted directly to the printed circuit substrate there, but it's not Invader shaped LED, it's just if you like, a stencil almost, where the light shines back from behind. And the last one that I opened didn't have this tape on. I don't know whether that is standard or not, but now I've removed it, you can see it's just a kind of matrix of LED displays, and then we have this kind of Space Invader shaped thing over the top. And what that means, of course, is that when you fire, that's the same as the Invader coming down. So the image is the same. Between here and here, it can only display one image, and that's this kind of thing here. Normal fare inside, really a tinted lens, and then these kind of carbon pill buttons on there, which will, I presumably, push down onto these switches on here. One microprocessor, a few transistors, presumably some driver circuitry for the LEDs. So yeah, we'll carry on digging into this. We'll see what else is in here. There we are, and at the back is a crusty piezo sounder. Again, lots of kind of crud and nastiness on there. And now we can see this modification in more detail. I'm just going to take this now and unwrap it. Oh, actually it's come straight away from the battery contact. There we go. It looks like maybe it was soldered, but I don't think it is. It's just wrapped around. This side it's wrapped around too, just maybe a little bit more thoroughly, but there's certainly no solder or anything like that on there. Right, so there is our modified power lead, our plugged power lead, which, as we've seen, is quite universal. Will plug into lots of different power supplies and would result in us putting 240 volts AC into this, where 9 volts DC should have been. I think I'll probably start by removing the plastics from the electronics, and we'll give the electronics a little try on its own, maybe with the bench power supply or something like that, and we'll take it from there, really. Alright, so now I have the plastics separated from the electronics. I just unsoldered these two wires from here. Generally, I unsolder them at the printed circuit assembly end rather than the piezo sounder end, because actually I have quite a lot of difficulty successfully soldering on to these piezo sounders. So by doing that, it just means that I don't have to remake those solder joints, and I can solder just at this end. At this end, I made a note of P1 and P2, which is where these two came from, and then I unsoldered this from the battery connector here. This one had broken off. So I'm going to set this aside a minute. We'll hook this up now to our power supply, and we'll see if it seems to sort of work when we get it hooked up to some power. So I have my power supply set to 9 volts, which is it takes 6 AA's, so that's right, 9 volts. Current limited at the moment, we'll see. Let's plug this in and see how it performs. This is just going where the batteries would have done. Obviously it's not a mains connection. And is there anything at all here? No. Nothing. Nothing at all. So maybe there was some irreparable damage was done to this. I can't help feeling that if it had had 240 volts applied to it, it might have had a bit more exciting damage inside than this. But yeah, nothing at all from this one. So it is going to need a little bit of work, and the first thing I'm going to do is just get my multimeter out and test that this switch is doing what this switch is supposed to be doing here. And we'll put it to continuity. So there is continuity there, and we're going to test to see if we have continuity across this switch. And it seems that we do. So on that basis, we'll put it now to volts, and we'll see if we have 9 volts when the power supply is connected between here, which is where it's supposed to come in, the ground terminal, and here, which is where the switch is. 9 volts, yeah, and here 9 volts as well. So 9 volts is going to the circuitry for our game now. However, our game seems a little reluctant to come into life. Alright, so having looked at this, there isn't that many components on it really. We have our 2 switches, which we've just tested we know to be good, with a few resistors which don't seem to be damaged, so my guess is that they're going to hold their value pretty well. There's a couple of ICs on here, LED driver or something like that, the other the microprocessor, and some kind of additional boards which carry the buttons or connections for the fire button there. So the next thing I'm going to do is check these 3 transistors. It looks like they are NPN transistors, and you've seen me test those in other games before, so I'm not going to show you too much of the detail of that. Suffice it to say, NPN, positive and negative, so if I put my meter onto diode test, then hopefully we should see about 0.7 or 0.8 of a voltage drop to the other 2. And if we see something other than that to those other 2 pins, then chances are we've got a short. But in this case, that one looks to be good. And just in case you can't see that, I'll just pop something underneath, maybe change the angle a bit. Yeah, there we go. And we'll check the next one. These 3 are identical. 0.8 and 0.8, and then the last one, which I'm guessing is going to be fine too, 0.8 and 0.8. The electrolytic capacitor I would have to take out to test, but if I'm going to take the trouble of taking it out, I'm probably just going to replace it with another one. My guess is, though, it's fine. If this has been connected up to a main supply, then there's a good chance that the processor will have been taken out, but I really don't know how to test that. So I think next steps for me now are a good visual inspection on this board, see if there's anything burnt or something like that which I didn't see, and then, you know, well, maybe that might be it unless I can find another one of these to kind of compare performance of. So I'm just going to take a look at this now with my loop and just see if there's anything on there that's obvious, any kind of damaged tracks or anything like that. So I didn't find any damage to the printed circuit assembly, but the good news is this is not the first Entex Space Invader that I've tried to repair. I'd previously tried to repair this one too, and this one had quite different problems. It had decent battery contacts and the electronics worked, but the enclosure was heavily discoloured and damaged and had become very brittle. Despite me managing to correct some of the cosmetic defects of the Invader enclosure by giving it a long bath in olive oil, it still remained very brittle and broke to the point that actually I couldn't really repair it. So I was pretty sure that I had kept the electronics and the battery contacts from the brittle plastic game, but when I went to try and find them, they were nowhere to be found. But third time, as they say, is a charm, and I did have a little bit of luck. I have this other Entex Space Invader, but this one is missing its battery door, so I thought, great, well, I'll take the battery door off the first one, and we'll just use that. So this is the one that currently we have in pieces. I'll take the battery door off that, lovely, nicely fitting battery door. And I'll put it on here, our other Entex, but what's this? It doesn't really fit. So it kind of goes in, but then the profile isn't right here, and there's a bit of a gap at the top. I thought, well, hang on. So these lower enclosures aren't the same. So there must have been multiple versions of this one. This one's made in Japan, as is the other one. But when I put them in the same orientation, actually they're quite different. They're almost a mirror image of one another, except that this one has a larger gap here, and this one has a smaller gap here. So these lower enclosures actually aren't the same at all. Anyway, well, you know, I thought, okay, well, let's hook this one up and we'll see if this one plays. Let's try that. And this is on our bench power supply still, so we'll go with the positive. This one has all the battery connections intact, which is quite nice. Alright, and negative on here. And we'll switch on. Oh, great. You probably won't see that in this bright light, so let's just dim the lights a little bit so you can see that. Oh, well, the clip's dropped off, but you get the gist of it. This is a working Entex Space Invaders. Except that actually it's not a working Entex Space Invaders because none of the buttons work. So we have one where none of the buttons work, and one where it doesn't work at all. So I'm really hoping we can get one good working one out of this pair, but we'll see. Next thing for me to do then is open up this one. I feel like this one probably has been connected up to the mains and hopefully didn't hurt anybody, but probably is a lost cause. So it seems what we have is one working game in a bottom enclosure which has no battery door and which I can't really use because of that, and one non-working game which I can't use in this lower enclosure because it's a kind of mirror image, or close to a mirror image, of the other one. Certainly the layout of the printed circuit is different. So this was the one that originally had our rather dubious kind of AC lead modification on it. What I'm going to try and do then is maybe switch the parts from this one onto this one and see if we can maybe get one working game, which then I can put back into the good enclosure with the battery contacts from the other game, and at least we'll have one handheld game that we can use safely running on batteries. That's my hope. Now, these processors have the same number, but, well, a similar number. This is an MP1211. This is also an MP1211, but there's some numbers underneath it which are different, maybe just the date of manufacture or something like that. Doesn't mean the programming's the same, though, and there are differences, as we say, in the printed circuit assembly, so it's going to be interesting to see how that works out. But before I do any of that, what I'm going to do is change out this capacitor first of all, since it is across the positive and negative lines, so it would have potentially taken the full brunt of the 240 volts if somebody had been bold enough to connect it across there. So I did replace the capacitor. The one that came out, of course, tested good, and putting the new one in had no effect on the functionality of the game. It still didn't work. Alright, well, it was worth a try. So next up then is this IC. I'm going to desolder this, which is going to take me a while. It's quite fine pitched, so I'll start the process and then I'll rejoin you towards the end. Okay, so I think that's our faulty processor. Unfortunately, I did do quite a lot of damage to the printed circuit assembly in the process of taking that out. But I think I'm going to be able to get away with most of them. I think I just need to be a little bit more careful when I take this part out, and hopefully when I solder it back in here I'll be able to make up those areas where unfortunately I did damage the track a little bit. So I did successfully remove the processor from the working board that is incompatible with the plastics that I have. So hopefully that was the last of the desoldering, and I'm hoping that this piece will come out more easily than the other did. Yes, it did. Just experience a little bit more patience. I wish I'd done the other one that way too. So despite the damage that I did when I was unsoldering the old chip, I was able to solder the working microprocessor back into the previously plugged board. So I now have the processor from the previously working Space Invader game into the Space Invader game, for which we have a functional battery door, but which previously had been plugged, and so we think that had damaged this processor. And I'm about to switch it on. Now I have switched this on, so I know what's going to happen, and unfortunately the news isn't good. I've dimmed the lights a little so that hopefully you can see. I can turn them off completely in a moment just to double check, but what's happening is that it's lighting up the flying saucer row where it should be lighting up the Invader row. As you can see, the Invaders aren't coming down, and the bullets from your ship aren't going up, and in fact your ship isn't eliminated at all, and there's a reason for that, and that is, if I just disconnect this, when I look at these two boards, and I should have done this before, obviously the layout of the board is different because they're a mirror image, but they're not quite a mirror image, and the way that this processor connects up to the LED display is different on each of these boards. So presumably, although this chip is an identical model, it has slightly different programming to account for the slightly different LED layout, and so consequently it won't work in this board. This board will only fit in this enclosure, and I don't have a battery door for this enclosure. This one will work but is missing the battery door, so again I've been defeated by our invaders. So I decided to check the assumption that I had made, that the connectivity between the microprocessor and the other components on the board was different from one version of the board to the next, and that consequently the programming on the chip had to be different too. To do this, I had to inspect the board and draw out the connections between each of the pins on the microprocessor and the various other components on the board. I needed to do this for both versions and put the two side by side. Alright, so now all I need to do is the same thing for the other board. And here it is. And there is some not great news. As far as I can tell, I use a different nomenclature on here and I shortened it a bit. As far as I can tell, they're the same. So, in fact, the layout of these printed circuits, although they are different, the connectivity of these two printed circuit assemblies is understandably the same, and so the programming on the ICs is probably the same. And of course, my assumption was therefore wrong. So now we know we have a working microprocessor, we have a good electrolytic capacitor because it's been replaced, we have good transistors because we've tested them, and we think the layout of the printed circuit board is the same and is good because we've inspected it with a magnifying glass. Which leaves only this mystery component, and I don't know what that is. Looks like maybe when this was plugged or connected up to AC mains, we lost both the processor and whatever this chip is. So I'm going to take this chip out of here and put it into this board, and then we'll put the processor that was originally in this board back into this one too. So I removed the second chip, I'm assuming it's some kind of multiplexer or driver for the LED display, and I installed it into the original board that had been plugged. I also had to install the microprocessor that I'd originally removed from the functioning board back into the plug board because I'd removed it from that board when I was trying to determine what the connectivity of the various components was. However, when I removed the processor for the second time, I'd further damaged one of the pads, so I had to install a wire link between one of the pads on the microprocessor and the LED driver. Yeah, that certainly isn't something to be proud of. It's a pretty hack job soldering-wise because of the damage I did to these pads desoldering it. But, you know, it might just work. Who knows? So next I need to turn my attention to the battery contacts, because the only lower enclosure for which we have a battery door has battery contacts that have corroded away. So I first need to scrape out those old battery contacts, which was quite a job, and then I can install the replacement battery contacts from the other lower enclosure, which has no battery door. So unfortunately, even that wasn't straightforward, and the positive lead, which had previously connected to the battery terminal, somehow didn't seem to be long enough anymore. Perhaps I'd just trimmed it when I was unsoldering it in the first instance. Anyway, that needed to be replaced with a new length of wire, and now we can finally get the game cleaned up. Oh, that's looking much, much better than it did before. It probably won't come out on the camera, but boy, that looks a lot better than it did before. So at this point, as we're just reassembling the game, I just wanted to mention something I'd spotted earlier in the video. When I first looked at the second game, I noticed that it was unresponsive to the key presses. This is probably due to dirty carbon pills or corrosion on the contact areas. I deal with this in another video, so I'm not going to go into too much detail about it now. But it didn't really need to be addressed on the board that was plugged. It was the other board that was exhibiting the problem, and it's the plugged board that went on to find its way into the final finished game. So I've had a bit of a tidy up, I've popped some batteries in, and now, with a bit of luck, we can finally take a look at our working Entex Space Invader. And I noticed actually when I was doing this, it's a Space Invader, not a Space Invaders, which may be how they got around copyright, I'm not too sure. But anyway, here it is. We're going to set it to the amateur setting at first. It has a Pro and an amateur. I think the Pro just increases the clock speed actually. So I think what will happen if I put it in Pro is it just plays a little bit faster, and maybe the pitch will change of the sound effects too because the processor is just clocking a little bit more quickly as well. Anyway, so let's power it on. Simple controls, left, right, and fire, just like you would expect. Oops, and instant death. So it's been quite a difficult ride for our little Space Invader game. It appears that both of its ICs were destroyed by the plugged experience, and it encountered even more PCB damage as a result of my attempts to repair it. Ultimately, with the help of a donor game, I was able to get it working again, and where we used to have two non-functioning games, one which was dangerously modified, we now have one perfectly safe and perfectly functioning game with its battery cover intact. But that just about wraps it up for our Entex Space Invader. It's a great little game and I'm very pleased to have it in my collection. I hope that you've enjoyed the video today, and if you have a second just to leave me some feedback in the comments section, that would be amazing. It really does make a huge difference to me and the channel. All of my subscribers are very important to me as well, and if you'd like to join those precious few, I'd really appreciate that too. But in the meantime, and as always, I'd just like to thank you so much for watching Retro Tech Repair. Oops. And back. And off we come with the lid.